Did we do NO2 plus? No. We're going to do NO2 plus. It's a cation. You haven't learned the names for those. All right, when we do organics, we typically just put all the carbons and hydrogen and oxygens linked together. When we get back to inorganics, we typically do it the steps. 5 electrons for nitrogen, 2 oxygens is going to give us 12 electrons, plus 1 charge, we remove 1 electron. So this is 4, this is going to give us 16 electrons. For NO2, how do we want to link things together? Probably we'll put the nitrogen in the center and then attach 2 oxygens to it. And then we'll complete the octets to the oxygens. How many electrons have we used up? 16, so I really can't put any more electrons. I've already used up 16 electrons. I only have 16 electrons, so I cannot complete the octet of the nitrogen. And so what do I do in this case? Double bonds. So I'll create. I'll probably, I need 2 double bonds in order to complete the octet here, nitrogen. So now that's complete. However, there is a charge. Do you see what the charge is? Formal charge. Plus on nitrogen. So positive charge here. The oxygens are 0, and so this gives us a net plus charge here. So this would be the NO2 plus ion. All right, let's do N2O. N2O is nitrous oxide or dinitrogen monoxide. It's a molecular compound. And so doing N2O, we'll do the same way. 2 nitrogens, 10 electrons, and then 1 oxygen is 6 electrons. So this gives us 16 electrons as well. Now N2O is kind of like H2O sounding. And so maybe it's an NON, NON, like H2O, HOH. It's symmetric, so it's okay. And then oxygen can be bridging like this. That is, it can link to 2 atoms. And so what I'm going to do is I'm going to put the nitrogens, the oxygens. So try to complete the octet on this nitrogen. Well, actually, oxygen should go first. Why should oxygen go first? It's more electronegative, so let's go ahead and do that. So it's 2, 4, 6, 8, 10, 12. And then I can complete the octet to this nitrogen. But that leaves this nitrogen with much less than an octet. And so we probably should split it, actually. Let's move that there, but still there's not an octet. So I need to figure out something to do. 2, 4, 6, 8, 10, 12, 14. I can do one more. That's 16. So the nitrogens have an octet, but the nitrogens do not have an octet, so I need to make an octet there. How can I get an octet? Yeah, maybe I'll double bond. Maybe I'll double bond with the oxygen here. So let's try that. If I tried to double bond with the nitrogen's electrons, I still wouldn't get an octet. And I'd have trouble here. Because that oxygen now has an octet, doesn't it? 2, 4, 6, 8, no, 10. We can't do that. Why? Oxygen's not allowed to have more than an octet. Anything in the second period is not allowed to have more than an octet. So this looks like it. So looking at the structure, does it look good to you? would you do next? Here. Yeah, let's take a look at the formal charges. So what are the formal charges? Okay, -1 on the nitrogen. +2 on the oxygen, and -1. This structure has an octet, but the formal charges are kind of high. You know, that means that nitrogen came out short 2 electrons, or not nitrogen, oxygen. Oxygen came out short 2 electrons, and nitrogen came out ahead 1 electron, each of them. And so the way the electrons are distributed, it doesn't look like it's the best, but if this is the best structure, that's what we got. Can you think of a better structure for this? Is there a better structure for this? Well, there is a better structure for this, but it requires a different skeleton. That is, rather than having the oxygen in the center, if we put the nitrogen in the center. And so it doesn't look as symmetrical, but we can generate a better structure this way. And so we have 16 electrons, so which one do we complete first, oxygen or nitrogen's octet? Oxygen, didn't do that. And then this nitrogen, that takes care of 16 electrons. And so the middle nitrogen doesn't have an octet, so we're going to have to form multiple bonds here. And so who's going to sacrifice first, nitrogen or oxygen? Okay, so let's have nitrogen sacrifice first, and then we'll generate a double bond here. Okay, we're still short of an octet. So who will make the next sacrifice? Nitrogen sacrifice. Whose turn is it now to sacrifice? Nitrogen or oxygen? Maybe you think oxygen? Yeah, okay, let's try oxygen. So if oxygen, we end up with this structure. The good thing about this structure is everybody has an octet. The bad thing about this structure is what? Is there anything bad about it?
Formal charge.
The formal charge. What are the formal charges? And then, yeah, 0. And so basically what this says is that one nitrogen gains and the other nitrogen lost an electron. So that's here. We'll call this choice 1. However, let's say rather than the oxygen sacrificing, let's say the nitrogen sacrifice. So we'll go to choice 2. We'll make that over here. And so let's say nitrogen sacrifices another lone pair to make a triple bond. We end up with this structure. The good thing about this structure is everybody has an octet. And then bad thing about it is there's still a formal charge. What are the formal charges? Here. This nitrogen is 0. This nitrogen is plus. And this oxygen is minus. And so it turns out there's no way to get rid of the formal charge. And we cannot expand the octet. But you know, I'd like to expand the octet. So for example, if we expanded the octet here, we could get rid of the formal charge. That is, let's make another bond here. And so if we go triple bond here, What are the formal charges here?